Welcome back, everyone. It's week 3, lecture 2. We're going to talk about reliability and validity of measures and how you establish those things. So a good measurement instrument is, number 1, reliable. Number 2, valid. I'm assuming you don't know what those mean right now. So you can design a fantastic study. You've got great hypotheses. However, if the measures you use for your constructs are garbage, so the fancy way of saying that is poorly designed, your study's probably going to fail. And I see it not infrequently, unfortunately. So you want to use good ways of measuring your constructs or measuring your variables. So got some examples here of things that are reliable but not valid. They're consistently in the same spot, but it's not hitting the middle of the target. And we got one that is both not valid and not reliable. The shots are all over the place and not hitting the center of the target. And then on the right, you've got something that they're pretty close together and they're also hitting the center of the target that is valid and reliable. So what's reliability? Reliability is when a measure consistently produces stable and precise estimates. So consistent, stable, precise. So if a measure gives you the same results or similar over and over, then it's reliable. So some synonyms for that are dependable, consistent, stable, trustworthy, accurate, predictable. Those are all things that mean a measure is reliable. So some examples. If I have a tape measure and it provides length measurements of objects that are consistent with those from other tape measures, we'd say that tape measure is reliable, right? If it gave me measures that were different from another tape measure, you'd be like, what's wrong with this thing? It's clearly not reliable. Well, people who take an IQ test several times over their lifetime get similar scores. So they're changing, right? So IQ is supposed to be something that's mostly static unless you have some severe trauma or something. If indeed IQ does not change that much over the course of their lifetime over multiple measures, you would say it is reliable. How about this one? It's a little weird. So what if you had a clock that's consistently 15 minutes ahead of time? Is it reliable? Yeah, it's reliably 15 minutes ahead. But what it lacks is validity. It's not a valid measure of time. So it's not giving you the right time. So we'll talk about validity next. So validity is when a measure captures the intended construct. So you've got a questionnaire or whatever ruler, and it's capturing the thing it's supposed to. So the way I usually say this is when a thing measures what it's intended to measure. So that's honestly the book definition of validity. Is a thing measures what it's supposed to be measuring, not other stuff, and just the thing it's supposed to be measuring. So some examples. If a course midterm includes fair questions that cover the full breadth of content taught during the first half of the semester, is it valid? Yes, that's what a midterm is supposed to cover, is the full breadth of content, not just the first week, not just the last week, the full breadth of content during the whole semester. That would be something that's valid. It's measuring your knowledge of all material during the first half of the semester. How about, is the number of followers or reposts a person has on social media a valid measure of their popularity? I mean, maybe, right? If they're organic, like people are posting or reposting and commenting and they're real people, sure, maybe that is sort of a way you could operationally define popularity on social media. But you can also buy followers and retweets and whatnot, so maybe it's not actually a valid measure of how popular. How about DMV's written test? So used to work there, helped design it. It's supposed to measure driving rules and laws, knowledge, etc. If the reading comprehension level that's required of the test is too high, is it still valid? Is it still a valid measure of your knowledge of rules of the road and safe driving practices? No. It's measuring something else beyond just safe driving rules and driving practices. It's also measuring your reading comprehension, which it's not supposed to, right? So that would invalidate the test. So if you got a fuel gauge in your car, it always shows that your gas tank is empty, even after a fill up. Is it a valid measure of the vehicle's fuel level? No, sure not. However, it's reliable. So it's reliably broken, right? Kind of like the clock. So things can be reliable but not valid, but the other way around is not the case. Can never happen. Can't have validity without reliability. And we're going to talk about that. All right, so there are 3 ways that you can establish reliability. That is, that a measure consistently produces precise measurements. One's test-retest reliability. There's alternate forms reliability, internal consistency reliability, and there's 2 subparts in there. There's split half reliability, which we'll talk about all these in more detail. Then there's Chromebox Alpha, which is super duper popular measure of reliability. But that's it, man's best friend. So how do you establish test-retest reliability? So this is going to blow you guys away. It's called test-retest. Guess what you do? Well, you give a test or measure, and then you give that same measure or test again. So the name literally tells you what it is. So the measure it produces, so test-retest reliability tells you that a thing produces stable and precise estimates over time, right? Because you're giving a test and then later over time, a retest, it establishes that a measure gives consistent results over time. So if the same health questionnaire is given to the same patients at each monthly doctor's visit and the results are similar, then that health questionnaire has test-retest reliability. If you get crazy things one time versus another, then you know what, maybe not. Like there's going to be a little bit of difference, of course. People change over time, but they should be fairly consistent. So if some sort of age cohort takes the same IQ test every 10 years from ages 15 to 75, and IQ scores are plus or minus 5 points difference over their entire lifespan, so they only go up or down 5 points, you'd say that's a pretty darn reliable test, given that this thing can go from whatever IQ goes to 15 to what, 160 or so. I don't know. Anyway, that's not much change. You would say, yeah, that's a pretty reliable measure of IQ. It's giving consistent scores over time. How about crime witnesses? Are crime witnesses who change their stories across interviews considered reliable witnesses? Nope, they're not. They lack test-retest reliability, don't they? If you took a calculus class as an undergraduate, would you get the same score on the final if you took that final now? No. But does that mean it's not reliable? Well, probably not. I mean, your knowledge has changed, right? Your knowledge of calculus has changed. So it wouldn't be a reliable measure. It's not meant to be a reliable measure of your sort of knowledge over time. It's at a point in time. So you wouldn't use test-retest reliability to establish that your final exam in calculus was reliable. You use something else. Maybe this one, alternate forms reliability. Again, the name literally tells you what it is. You give alternate forms of things to establish reliability. So this is when a measure consistently produces stable and precise estimates, over different forms of the measurement instrument. So for example, if different versions of the bar exam, the law exam, are given to the same group of lawyers at the same time and they give similar scores, right? You give them Form A and Form B of the bar exam, you would say, yeah, this bar exam has alternate forms reliability. Different forms produce similar results. So when teens fail Form 1 of DMV's written tests, so they come in and they fail their Form 1, their first attempt, they usually fail same-day retests that they take after that, regardless. Whether it's Form 9 through 10, they usually fail the second time as well. This is true, by the way. So what that tells us is that whatever these tests measure at DMV, they give consistent results across forms, right? You know, there's Form 1 through 10. Maybe you didn't know that. But anyway, there's 10 forms. So it has alternate forms reliability. So if you end up hating every movie and restaurant that your sister-in-law recommends, regardless of the genre or type, then her bad taste has alternate forms reliability. Oh, God, is that Pearl Harbor? So anyway, that one's kind of a joke, but you get the point. Consistently bad. All right, so then we have internal consistency reliability, and there's 2 types of this. So internal consistency reliability is a measure of the extent to which a measure consistently produces stable and precise measurements internally. So the parts of it sort of are consistent with each other. So items on the same measurement instrument are internally consistent and result in similar measurements. Well, what use is that? You're probably thinking. Fine. So there's two subtypes of this. There's what we call split half reliability, and this is when a measure is internally stable and precise because performance on its two halves are similar. So yeah, people, they literally establish reliability by doing like odds versus evens and saying, look, people get similar scores on both halves of the test, something like that. So, but you know, for something like Beck depression inventory, the BDI, if you split it in half, people get like the odds, their depression score on half of them is similar to the depression score they get on the other half of them. The items, that is, say there's 20, 10, and 10. You'd say, yeah, this thing is internally consistent. That is true, right? It gives similar scores across the items inside the test. Cool. If they're not strongly correlated, the items are not really consistent with each other, right? Like if you split it in half and you get two totally wildly different scores from the first half or second half, or odd versus even, or whoever you split it, you'd say, yeah, whatever this thing's measuring, it's not consistent, even inside the measure itself. So first half or second half comparisons of things aren't appropriate when they get harder. So like the GRE, you would never do first half of the test versus second half. That's goofy because like they're not equally difficult first half or second half. They get progressively harder. So again, internal consistency reliability, same one. We're going to talk about Chromebox Alpha, and that's Chromebox. Chromebox Alpha, or just Chromebox, depending on who you're talking to. It's a measure of how internally stable and precise a measurement instrument is because it's the average correlation of performance between all possible split halves. So that split half reliability we just talked about was one half versus the other half. This is all possible ways of splitting a measurement instrument or a test in half, and you correlate the two halves with each other. It's the average correlation, which we learned about in the last lecture. So what you would expect is if a measurement instrument is internally consistent, you get a strong positive relationship between, on average, between any possible way of splitting that thing in half and correlating with it, the two halves together. So it is a value that ranges from 0, no relationship, to 1, perfect. So it's like a one-sided correlation coefficient. Yeah, we're not doing this by hand. SPSS does this. So we're going to have SPSS calculate this for us. It's actually really easy and will amaze your dissertation committee when we do it. They think it's super hard. You literally throw things in a box and click OK. So alpha, this is different than the alpha level. This is Chromebox Alpha. It's routinely reported in the manuals for your psychological measurement instruments. There is a standard. You want things to be at least 0.8. So 0.8 or higher for you to say, yes, this thing is internally consistent. It's a reliable measure. So DMV's test, for example, the 36 item one you take, the driving test that you take, is not internally consistent. Its alpha is 0.7, which is less than 0.8. So we found it to not be very internally consistent, but you know, to some extent, it's measuring different things across the test. There's lane position, parallel parking, speed. Like they involve different skills. And so it's amazing we even got 0.7, but it's not super high in terms of internal consistency. So let's answer the following questions about reliability. Which produces more consistently stable and precise measures of weight? Your home bathroom scale or a hospital scale? Even that one with the sliding weight. Well, it's the hospital scale. They're way more precise. You'd be amazed at how precise those things are, especially compared to your bathroom one, which is on linoleum or carpet or who knows what. They're way more accurate. So would a tape measure or a ruler be more consistently stable and precise for measuring the length of rooms? Well, think about it. A ruler, you're going to have to flip it, right? To get to one end of a room to another. Tape measure is probably going to be more consistent because it's just one measure. It's the measure of the tape. You're not like, you don't have this error introduced by flipping the ruler over itself for each foot. So you'd probably say the tape measure is going to be more reliable. How about an anxiety questionnaire? Is it better to use 1 item or 10 items? What's going to give you a more stable and precise measure of someone's anxiety level? Well, there's a reason we don't have questionnaires that are 1 item. How anxious are you? 1 to 10 is not a good way to measure things. You want to sort of break it down And remember, science is analytic into its little subcomponents, right? How anxious are you about this and about that and about different things and all the time, and sum them up, you get a more precise and stable measure of their anxiety. So having more items results in more consistency in general, because measurement error decreases as the length of a questionnaire increases. Don't know if you know that. So basically, measure twice, cut once is the rule for reliability. So if a measure is not reliable, it can't be valid. If a measure doesn't produce things that are reliable, that is stable, then how can it be measuring something, the same thing, validly, right? If every time you use something, a measurement instrument, you get totally different scores, what the heck is it measuring? It's not even reliable. It can't be valid. Valid meaning measuring what it's supposed to be measuring. So if scores vary greatly across times, forms, or items, then how can we know whether the measurement instrument is really measuring that same construct? We don't. How can an IQ test that gives wildly different scores be measuring stable IQ, right? It's supposed to be stable. So if it's giving different results, it's a crappy IQ test. It's not reliable. So a correlation coefficient that is R or an alpha of 0.8 or greater is generally considered acceptable. The higher the better. That does not mean a measure is reliable 80% of the time, by the way. It's not what it means. It just means, how strongly scores are related across time or forms or items, that sort of thing. Higher R alpha equals higher reliability. So validity, the other side of this coin, is when things measure what they're supposed to measure, right? And there are three ways to establish that a measure is measuring what it's supposed to measure. That is, that it's measuring the intended construct. So as an example, does the SAT measure future college performance, or is it just measuring people's test taking skills? Often wondered. So there are the three ways. There's content validity. So content validity has two subtypes, face validity and sampling validity. There's criterion-related validity, and again, two subtypes is the theme here. There's concurrent validity and predictive validity. And then finally, construct validity, you're never going to guess two subtypes. Convergent validity, divergent validity. All right, so what's content validity? So content validity is when a measure captures all the important information about some intended construct. Okay, so it captures the whole universe of information that's important for measuring whatever the construct is, whatever it is you're trying to measure. So one type, sort of content validity is face validity. Face validity is when, well, it looks like it measures what it's supposed to be measuring, right? So, it's a test of reading ability, and it has reading passages, and there's questions about the passages. There isn't math problems, right? There isn't trig on there. Okay, it looks like it's measuring what it's supposed to measure. And we call that face validity. So, turns out, though, that it's not necessarily the case that just because something looks like it measures what it's supposed to be measuring, first of all, that it is measuring what it's supposed to be measuring. And second of all, things can look like you have no idea what they're measuring, and they're actually measuring some underlying construct. So face validity is neither not enough, and it's also not sufficient, and it's also not necessary for establishing validity. So, for example, low face validity can be a good thing. So when you don't want people to be guessing what you're measuring, it's sometimes good to have low face validity. So the MMPI, Minnesota Multiphasic Personality Inventory, is like 500 questions, just like yes, no. I don't have hair. I wet the bed. It's just all tons and tons and tons of questions. And it's really hard to lie on because you have no idea which questions correspond to like what psychological personality characteristic they're trying to measure. So I've seen cases where, again, face validity is thrown off by putting tons of questions on a questionnaire, but you only care about a handful, and the whole point is so they can't guess what you're trying to measure. You bury it in a bunch of other questions. So face validity is not sufficient to establish a measure is actually valid. Content validity, however, has a second type called sampling validity. Sampling validity is a good type of validity. It's sufficient for establishing validity. Sampling validity is when, based on expert assessments, the measure you're using captures all important aspects about the intended construct. So whatever it is you're measuring, experts agree this thing's capturing information about all of it. So, for example, an employment test, such as those used to hire firefighters. So you have experts define all the relevant firefighter KSAs. That is, what knowledge do they need, what skills do they need, and what abilities do they have to have. You have them define those things. And then you bring in some industrial organizational psychologists, and they make questions or they create tasks that measure each of those important skills that the experts identified. So to the extent that you measured all those things, you would have content or sampling content validity. You have measured all the aspects that experts say are important. So as a counterexample, how about an IQ test that only included verbal ability? That would not be content valid, because IQ is much more than just verbal ability. It's a valid measure of verbal IQ, I guess, but it's not a measure of IQ per se, the whole thing. So if experts agree that all important facets of the intended construct are included in a measure, then it has strong content or sampling validity. Next type, criterion-related validity. So criterion-related validity is when a measure is related to some criterion, such as other concurrent measures of the same construct or future performance about that construct. So criterion-related validity is when the measurement instrument you're using is related to other measures like it, or it predicts future performance about the construct you're measuring. So first one is concurrent validity, and this is when a measure is strongly correlated at the same time with other measures of the intended construct. So what does that mean? So you would expect, for example, that clients with depression diagnoses score higher than non-depressed clients on your depression measure, right? If so, that's true. You have evidence to argue that you have concurrent validity. They were diagnosed as depressed, they score higher than people who aren't. Suggests that this thing's actually measuring depression. So you make a new anxiety measure, and do the scores correlate with existing validated anxiety measures? So if you make one and the scores on yours are consistently positively related to some other measure, like the state trait anxiety inventory, you've got evidence that your measure of anxiety is truly measuring anxiety. It's measuring the thing it's supposed to. It's got criterion concurrent validity. So for DMV's written renewal test, when you got to renew your license, do drivers who have high crash and ticket rates when they come in, take the test, do they tend to do worse? No, they don't actually. It turns out that people get tickets and in crashes for reasons that don't have to do with their knowledge. They get tickets and in crashes for other reasons, like not paying attention, or they drive a lot, or lots of other reasons. So it does not have concurrent validity. Hope that makes sense. Maybe that's postdictive validity. So when there's a stronger relation to current performance, it indicates better criterion-related concurrent validity. So this is same time. Next one. Predictive validity. So predictive validity is when a measure accurately predicts future performance regarding the intended construct. So it can predict the future based on their performance today. So do people who score high and low on your employment test end up being good or poor employees, respectively, in the future? If so, you would say this test has predictive validity. It predicts who's going to be good and who's going to be a bad employee. Do people who score high on the GRE actually perform better in graduate school than those who scored low? If so, I doubt it, but if so, it has predictive validity, right? So, yeah. Do people who perform poorly on DMV's driving test have higher accident rates? Right? That's what it's supposed to measure. So the short answer is sort of it's a weak relationship. It's weak criterion-related predictability, validity, and the reason is there's sort of a restriction of range, really, is the problem. If you perform too poorly on DMV's test, we don't give you a license. So we don't have the full range of ability. So for those who do pass, it's a weak relationship. They get more errors. They tend to get higher crashes. So stronger relation to future performance indicates better criterion-related predictive validity. Construct validity. So the final type, two subtypes. This is when a measure actually captures the intended underlying theoretical construct. Well, isn't that what we've been saying the whole time? Now, this is like series of studies establish construct validity. And we'll talk. Here we go. So this is when the intended construct is part of some sort of underlying model or theory of behavior, and scores for your measure are found to be related to similar constructs, but not related to irrelevant constructs. So it's measuring the things related that it should be, but it's also, you show it's not related to things it shouldn't be. Woof. So this is established by doing many studies over time to demonstrate that a measure has both what we call convergent validity and divergent validity. So that hospital survey we've talked about in the past, where they randomly sample people who are inpatients, adults, give them this survey, and I said that it's probably suffers from response bias, the halo effect, where everything's either great or everything's either bad, depending on their experience, regardless of how things really were. So it's given to these patients, and they measure all these things. So do the scores truly capture patient experience, or are they just capturing general feelings about their health outcome? To the extent it is not measuring actual patient experience, it's just measuring their halo sort of feelings about how things generally went, it does not have construct validity. So again, this is the halo effect. It's a tendency for positive impressions that you have of a person or company. In one area, like they're really good in this one area, it positively influences your opinions in all other areas. Like it's a halo, it spreads, like they're just angelic. So do people who had bad health outcomes trash everything about the hospital? Do people who had good health outcomes just say everything was fantastic, even the food? And everyone knows hospital food is not that great, right? So if scores on this thing truly measure patient experience, should they be strongly related to whether they had a good or bad health outcome? I would argue probably not, right? You should have people who said, yeah, the communication was good, even though, I got bad news. That should happen. Or people who say, well, they cured me, but the food was gnarly. Like that should happen, and it doesn't. So I would argue it does not have construct validity. All right. So getting back to non-example, establishing over time that a measure is both convergent and divergent validity is construct validity. So convergent validity is when a measure is strongly correlated with constructs that are related to the intended construct. Okay, so it's correlated. Scores on your measure are correlated with things they should be correlated with because they're similar. So, for example, a measure of college success should correlate strongly with grades, employment after graduation, perceived success, later income, etc. College success should be strongly correlated with all those things. A measure of leadership should correlate strongly with other constructs related to leadership, such as your communication skills, organization skills. Those are all things that are important for being a leader, so they should be associated with your leadership questionnaire. So it's kind of like concurrent validity, but there's lots and lots of measures. It's not just measures of the same thing. It's measures of the same thing and measures of related constructs. It's a whole bunch of studies that do these. Don't do this for your dissertation. So divergent validity is the opposite. This is when you establish that a measure is not strongly correlated with constructs that are not related to the intended construct. So the other one was you show that scores are related to things that are similar to your construct. This is you show that scores are not related to things that are dissimilar or shouldn't be related to your construct. So for example, your measure of leadership should not strongly correlate with unrelated abilities like cooking skills or painting skills. Those have nothing to do with being a leader, so why would they be strongly correlated? So you want to show that they're not strongly correlated with leadership. Your math test should not be too strongly correlated with reading comprehension. So there is general IQ, there's always some correlation, but in general, people who aren't that great at reading comprehension, people who are great at reading comprehension should be able to perform well on your math test. Otherwise, it's measuring something else. It's measuring reading comprehension. So establishing over time that the measure is strongly related to things it should be, but not strongly related to things it should not be, suggests that the measure is actually capturing the theoretical construct it was intended to measure. That is, it has construct validity. Oof. So a self-esteem example. So to establish construct validity for self-esteem, you'd want to demonstrate that it is related to things that are important to self-esteem, and that it's not related to things that are unimportant for self-esteem. So here we have self-esteem in the middle. It overlaps a little with self-worth, self-confidence, self-appraisal, social skills. Those are all things related to self-esteem. But it's not strongly related to things it shouldn't be. Aggression, driving skill, memory. They might be related to some of the intervening concepts, but they're not related to self-esteem itself. Finally, establishing that something's valid requires that you first establish that the measurement is reliable. Reliability is a prerequisite for validity, but it is not sufficient for it. Just because something's reliable doesn't mean it's valid, but you can have something that's valid if it's not reliable. So, in other words, a measure can be reliable without being valid. So, for example, is a reliable ruler a valid measure of social skills? Well, obviously not, right? So, yeah, it's reliably measuring things, but it's not measuring social skills. So it's reliable and not valid. It's a reliable measure of length, but not a valid measure of length, but it's not a valid measure of social skills. So if I weighed your head at the same time each day, once a day for a week, it would be virtually the same weight every day. It'd be highly reliable. But that doesn't make it a valid measure of IQ, right? It's reliable but not valid. So these are reliable scores that are not capturing the intended construct. They're reliable but not valid. So a measure cannot have low reliability and high validity. If the measure isn't consistent, it cannot be a valid measure of the same construct over time or internally, etc. So the obvious exception being things that vary dramatically, my wife's mood, for example,